Good day, engineers. Today we'll be having a lecture about a certain past board exam problem in hydraulics. This is under the hydraulics and geotechnical engineering subject for CE licensure examination. So the problem states that the flow rate of water through the pipe shown is 50 liters per second under a total head loss of 9 meter, and assumed that C value is 120 for all pipes. So we are tasked to calculate the flow of water through line B, this one, and the head loss in line B also, and third is the diameter at line C. Now, from the problem, we have a flow rate of 50 liters per second. So that is the Q, which is also equal to 0.05 cubic meter per second. Since we all know that 1 cubic meter is equal to 1000 liters. So the total head loss is 9 meters. That is the head loss from line A to line D. Now, the assumed value of C is 120 for all pipes. Now, this C is actually the Hazen-Williams coefficient. That is for all pipes. Now, from the figure, we have line A. It has a length of 300 meter and a diameter of 200 mm. Line B has a length of 266 meter and a diameter of 160 mm. At line C, we have a length of 190 meter, and we do not have a value for our diameter. At line D, we have a length of 510 meter and a diameter of 250 mm. Now, for us to solve this kind of problem, we have to identify the head loss per pipe. So we have to identify the head loss per pipe. So the head loss per pipe, since this is a Hazen-Williams problem, so we have a formula of a head loss due to friction by Hazen-Williams formula of head loss is equal to 10.67 L Q raised to 1.85 all over C raised to 1.85 times D raised to 4.87. So first, the head loss at A. Head loss at A is equal to 10.67 L. What is the L? 300. Q, we have Q. The Q at A is equal to 0.05 cubic meter per second. Also, the Q at D is also equal to 0.05 cubic meter per second, since A and D is connected in parallel with each other. Now, our Q at line B is unknown and Q at line C is unknown. We have to identify that one. So Q at A is 0.05 raised to 1.85 all over C. C is 120 for all pipes, and raised to 1.85. D is 0.2 raised to 4.87. So this will actually result to a value of 4.528 meters. This is the head loss in pipeline A. Now, the head loss at B is equal to 10.67 L. L at line B is 266 meter. So Q at B is unknown, so QB raised to 1.85 all over. C is 120 for all pipes, 1.85 raised to 1.85 times D 0.16 meter, that is equivalent to 160 mm, 4.87 is equal to. Now for this head loss, we just have to identify the value of this one here, since we still do not know the value of our QB. Now for that, the answer is 3037.361 Q sub B raised to 1.85. So for head loss C, let's just it is still unknown, so we'll just find it out later. So head loss at D is equal to 10.67. L for D is 510 meter. So 510 multiplied by Q at D is 0.05 raised to 1.85 all over 120 raised to 1.85 times our D for diameter for line D is 0.25 meters raised to 4.87, and this will result to a head loss at D of 2.596. Now, the question number one is calculate the flow through line B in liters per second. We can actually find that one if we have a value for our head loss at B. Now that is the question number two. Now for us to identify the answer for question number one, we still have to identify the answer for item number two. So we'll just proceed with the item number two, which is the head loss at B. Now the head loss at B, we can get that one by determining the total head loss of the connection. Now the total head loss of the connection is head loss is equal to head loss at A plus head loss at either B or C. Why is it na either B or C, head loss B or C? It is because pipelines B and C is connected parallel with each other, so the head loss at B is just equal to the head loss at C. So we will also add the head loss at D. So okay, the total head loss at as what is stated in the problem is 9 meters. So we have to plug in that one. 9 is equal to head loss at A. We already calculated that one, and that is equal to 528. Sorry, 528. 2.528. 4.528. 4.528 plus head loss at B. I'll just put that one as head loss at B na lang. So head loss at D is equal to 2.596. So our head loss at B is equal to, transpose all values to the other side of the equation. So 9 is 9 minus 4.528 minus 2.596. So our head loss at B is just equal to 1.87 meter. Now from our choices, we have head loss of 2 meter as the closest value to 1.87. So we have to choose letter C. So okay, so next we will be identifying the flow through line B. And since we already have the value for head loss at B, we can now solve for our flow through line B. So we have head loss at B is equal to 3037.361 Q sub B raised to 1.85 plug in the value for HLB, which is equal to 1.87, 3037.361 QB raised to 1.85. Now divide all both side of the equation by 3037.361. So we have Q sub B raised to 1.85 is equal to 1.87 over 3037.361. Now, for us to get the value of QB, we have to raise both sides of the equation by 1.85. That is to limit our use of shift solve, since we all know that the CE board exam really is ang calculator po is very crucial. So as much as possible, if you can simplify the equation further, so we have to utilize that one, so that we will not be depending so much on our shift solve function. So our QB now is equal to 0.0184 cubic meter per second. Now, since our choices is in liters per second, so we have to convert. QB is equal to 18.4 liters per second. Since, diba, we have 1 cubic meter is equal to 1,000 liter. Now, going back to the choices, we have 19 as the closest value to 18.4. So, we have to choose letter D. Now, what about for our question number 3, the diameter in line C? So, from our figure, we can see that pipelines B and C is actually connected parallel with line A. So, with that, I'll just state 3 diameter of pipeline C. So, as we all know, the pipeline A is connected in parallel with pipelines B and C. So, with that, we can have an equation of Q QA is equal to QB plus QC. Now, since we already have the value for QA and QB, we can now identify the value for our QC. QA is actually equal to 0.05. It is already given in the problem. QB is this one. So 0.0184 plus QC. So we can solve for our QC, that is equal to 0.05 minus 0.0184, or QC is equal to 0.0316 cubic meter per second. Now, for us to determine the diameter of pipeline C, we have to use the equation for head loss for Hazen-Williams formula. So, head loss, di ba? Head loss at C is equal to 10.67 length of C. Pipeline C is 190. So 190. Q at C is 0.0316 raised to 1.85 all over. C value is 120 for all pipes. 1.85. The diameter is unknown. 4.87 raised to 4.87. Now, since from our drawing we have pipeline B and C is actually connected in parallel with each other, so we can say that head loss at P is equal to head loss at C is equal to 1.87 from our head loss that we have solved before. So 1.87 is equal to 10.67, 190, 0.0316, 1.85 all over 120 raised to 1.85 times d raised to 4.87. Now, multiplying um, both terms by this quantity, so we can say that 1.87 times 120 raised to 1.85 times d raised to 4.87 is equal to 10.67 times 190 times 0.0316 raised to 1.85. Now dividing both terms by both sides of the equations by 1.87 times 120 raised to 1.85, we can actually cancel this one. So we'll be left with d raised to 4.87 is equal to 10.67 times 190 times 0.0316 raised to 1.85 all over 1.87 times 120 raised to 1.85. Now, for us to determine the value of d, we can raise both sides of the equation by 1 over 4.87. So, our d now is equal to um, 10.67 times 190 times 0.0316 raised to 1.85 over 1.87 times 120 raised to 1.85. This is actually equal to 0.183 meter, or in mm that is equal to 180 183 183 mm. So this is our final answer. This is the diameter at C. From the choices we have, the closest value is this one, the letter A. So we have to choose A. So that will be all. Um, Stay tuned for other tutorial videos about civil licensure examination. So